Hello and welcome. This is Cujo Sound, WhiteNoiseTrash, and I'm Bjorn Jacobsen. This is my Unity series where we're digging into various tools in Unity that we can create on our own without much coding experience. One of the problems that we're going to get now is that the scripts I made in the past couple of videos and the script that we're going to do right now is they are quite they get a bit tricky, but trust me, as a non-programmer myself, it took a while to get used to these. So today we're going to be digging into how we can crossfade between two snapshots in our audio mixer instead of just transition between snapshots over time, where the crossfade can simply just through a collider tell you how far you are. And that makes a lot of sense, as you can see here, in not exactly in this level, but if you have a long corridor, let's say that goes down here, you want the snapshot to fade into maybe the room at the end of the corridor over the distance you've walked down the corridor instead of just over time. What I plan to do is basically also to place two really big colliders on the entire level in this case, so that whenever we walk around the level, we can change the wind sound just a tiny bit when you walk in one direction and when you walk in another direction. There are two scripts for today. I'm only going to present the first one, but there's a way more advanced script that you can also grab at cujo.dk-/scripts. It's made by Christian Schubert. He did a really awesome job doing it. The simple one that we're going to explain does not take rotation into account, which is important, but let's get into it. So if we want to alter something here, as you can see, if we press play, we can just walk around. And the controller mixer that we made actually last time that triggers still works. Here on the wind sound, we can see that it still works. So, yay. Anyway, we are going to need a new empty object out here in the open and not a child of anything else. We are going to call it, let's call it Snapshot Crossfader. Yeah, because in that way we know what this is. It needs a new script, and we're going to go through this script together. So let's call it the Snapshot Crossfade. Snapshot Crossfader. It can have the script called that. Yeah. So let's go in here and edit the script. And once we're into this script, it's going to get a little hairy, but if it's too fast or anything, you're more than welcome to fire away in the comments. We are definitely, because we're going to need an audio mixer, going to be using Unity Engine .audio. That's for sure. And we know that we are going to require a collider. So we are going to require component type of box collider. You can also here after the parenthesis say comma and then say type of audio mixer, because we need an audio mixer. Now this require components, you can do a comma and then write up to 3 different components, and we need an audio mixer. The reason why we need an audio mixer is because, weirdly enough, the snapshot crossfade controls is happening on the audio mixer and not on the actual snapshot, which the transition to over time does. So this is a little different. What's happening is that here we are going to we need a public void, sort of like establish a on trigger stay. collider other, like this. On trigger stay means that it's active all the time when you are inside the collider. It's different from on trigger enter because that only triggers once you enter the collider. We want to do something as long as we are inside it. Up here in our public class, we are going to need a public vector3. And vector3, that's a vector. I'm not sure what that actually is, but I know that a vector3 has 3 coordinates. I'm not really sure. It has 3 coordinates. It's the 3 coordinates that you see in Unity all the time, like the position X, Y, and Z. And that's the values that we're going to need. So we need a public vector3, and we're going to call it travel direction, like that. And we also need to make sure that our audio mixer is there. So we have an audio mixer, and we'll just call it the mixer. If you get deeper into these kind of scripting, programmers will most likely tell you to name these differently. But for now, it's fine by me. We also need to establish that we need which 2 script snapshots to go through. So we need an audio mixer snapshot, and let's call it snapshot 0. The reason why we're going to call it 0 is because the array that we are going to create later starts at 0. It doesn't start at 1, it starts at 0. So let's call this one here snapshot 1. After that, we are going to need to make sure that our private box collider, which we're going to be using, is called, let's just call it the collider. Here we are. And we're going to need at least 1 float value. So we're going to create a private float called the value. Nice naming. The naming convention is strong with this one. Back in Unity here, that means that we can now see the things that we have added, the values, the audio mixer that we can drag to it. So we can actually choose our audio mixer here, our ambience mixer, and we can choose our snapshots, snapshot 1 and snapshot 2 that we had from previously. You can see the snapshots down here. Now, the only difference between the 2 of these is that one of them is just set to plain 0, and the other one is increasing the volume by 10 dB, but has a low pass filter that is quite aggressive. So the difference is that, well, we can actually listen to it. Hang on. That's the difference between the 2. So that difference will be quite easy to notice. That's also why we have it, so that we can run around the level and check it out. So let's see here. Down here by our Snapshot Crossfader script, we're going to remove this because if we add it again, you'll notice that a box collider and an audio mixer will occur because we know that if we add our Snapshot Crossfader script again, you will notice that the box collider is now automatically added to it. You could, of course, add it yourself, but that's the awesome part of making sure that we have these required components here. We did type in that it required an audio mixer. That's a bit difficult because that's in a completely different component, a game object that it needs this, but it's, let's say it's good practice to write in these whenever you need them. So let's move on here. We are going to need and make sure that here in our start, that we make sure that our the collider equals get component box collider. Here we are. And that means that we have now established that our the collider private here is now equal to the box collider connected to the object. and we will make sure that things stay that way. We are going to need some sort of initialization system because we need to know our arrays of audio mixer snapshots. So let's create a private void set audio mixer. And here, this is where the parenthesis really gets powerful because you can type in what kind of values you would expect this method here, this function, to need whenever you call it. So let's here write float. We'll just call it value. And what happens here is that now that when we add these things, whenever we call, let's say down here, let's say we called set audio mixer, you can always say 0.0f, which means that we are going to call whatever we are going here to call this function with these values, and then we're going to use these values here, which means that you can of course make this another variable and you can call it from there. But we are going to wait a little with that. So up here in our set audio mixer, let's create an audio mixer snapshot. Oh, God damn it. I have fat fingers. Audio mixer snapshot array, because we need an array. Let's call it TMP array, which is sort of like just temporary array. The problem with this is that we can make an array, and you can always make an array as big as you want, but we just need 2 audio mixer snapshots, because if we have more than that, this won't work. So temp array, it equals a new audio mixer snapshot number 2. So that means that we force our audio mixer snapshot array to be with a value of 2, which means 0 and 1. Good. So let's say here temp TMP array. Here the value 0 in our array equals our snapshot 0 and our TMP array number 1 equals our snapshot 1, like that. Good. So now we have established that we have a small array. We can check it out here in Unity when it's done loading. Whoop. Something wasn't right there. Temp array. That's because we don't have that temp array. You see, that's actually a nice error right there, because we didn't have a semicolon there. Then the next line just won't get it, which means that the ending of lines, semicolons, and everything like that, it's super important because things just won't work. And it's one of the most common things to make an error about. So make sure you check your semicolons before you start debugging a lot of other things. Okay, back in Unity. Press play. It works now. Good. So now we have a snapshot 0 and a snapshot 1. These are all connected to our internal array that we have inside. The reason why this is cool is that then we can't do what I just said, make the array bigger than snapshot 0 and 1. And that way we avoid the confusion of adding too many of these snapshots. The next thing that we need to add is that we need to add and force it to be a value between 0 and 1, because our snapshots, the audio transition between the snapshots only can only handle a value of 1, between 0 and 1. So if you fade between these, then it's not the actual value, it's the total value of the weights between snapshot 0 and 1 that needs to be 1 in total. So if it's, so you can't be 0.4 and 0.5 on the other. It needs to be 0.4 and 0.6 because else it won't equal the total number of 1. Then else it'll just do messy stuff. So we'll create a float array. The reason why we're going to create an array is because we need 2 values, obviously. Let's call them temp values. New float array with 2 values. Just like we did above with our audio mixer snapshots here. So TMP values number 0 equals 1 minus value. And TMP values number 1 equals value. It may seem confusing why we can just type value here, but that's because we have identified the setup audio mixer up here with that it takes an input of a float called value, which means that this up here, this down here is our temporary values between -1 of 1 minus the value that we send to it, and the other one is just straight up the value so that we can connect to that. We'll get to why this is important on. So now that we have established that, because we know that a transition between audio mixer snapshots takes 2 values and it takes a time frame, the sort of like the transition. And that means that we can sort of like create a smoothing value actually. So we're going to create a public float, and let's call it smoothing value. It's sort of like smoothing, so that you, instead of running straight through the collider, we'll just go from 0 to 1 really fast. You can set a value of half a second is enough to sort of like make the change flow a little better. So here we are going to say audio mixer. What did we call it? We called it the mixer. The mixer dot transition to snapshots TMP array, comma TMP values, comma smoothing value. That means that we now have here, we can basically just type in here, this is a smoothing over time. Here we establish the weight between our snapshots, and here we create the 2 snapshots and determine which ones to crossfade between. You don't need these comments, but they do. They help. They definitely help. Now here comes the tricky part, because we are going to now go down into our on collider trigger stay, and that's where math happens. And I hate math. I'm really bad at it. Now, to begin with, there's a couple of things. You may have noticed here in Unity that, let's say if we look at our character, it may have this. It's untagged. But in this case, we're going to call it player. And you will most likely, if you work on a project, you are going to have every object have a tag. And the reason why you want to do that is because, let's say you only want our player to interact with this collider. You don't want anyone else to do it. Then down here, we can say that if other, and other is established here because on trigger stay is only active if other is connected to our collider. So if other is null, and let me see if I can find that. There we go. This, maybe you remember that we had previously written and or equal, like, because and means just and something needs to be true and another thing needs to be true. This means or. So if whatever connects to our collider is null, then of course then it shouldn't do anything. Or if the other dot tag dot equals player, like that. Or on a Danish keyboard, it's the key right next to the backspace button, which is, I don't know what it's called. I think it's apostrophe or something. Not sure exactly. So, or if the collider is null, like that, then return. The reason why we type this in simply means that if whatever is connecting with our collider is nothing, or if it's anything else but the player, or if the collider simply isn't present on our object, just stop the code right here, because that prevents all this from being triggered, meaning that in case you add this script somewhere wrong, it won't mess up everything you do. Good. We can type in here, only do stuff with the collider if it's the player and there actually is a collider. Here we go. Good. And what we want to do is we want to, and here comes the math part. I have written this down and sort of memorized it, how this works. It took me a while, but it's not because I know how to do this. I just remember how it's set up, and Christian Schubert helped me quite a lot with it. So let's see here, vector 3. Let's make a temporary direction is it's the transform dot rotation. This basically means that in here in Unity, it is the transform rotation of this object here. Our snapshot crossfader, which is located here. You can see here, this is transform, and the rotation is these three values. Those are the ones we're going to work with. So transform rotation multiplied by travel direction normalized. Dot normalized. Good. Because we want the rotation of our object to be multiplied by the travel direction of the player. Dot normalized simply means that it makes sure that it becomes whole numbers or full values. It normalizes the values that we would need. And we need to normalize the result of that calculation. So let's make a new here. Vector 3. Let's call it travel progression. That's how far we have gone through our collider. So we're going to make a new vector 3, and we're going to call it other dot transform dot position dot x. That means that we're going to use because other is us, that's the player, and his transformed position, but only the x value. We're going to use that in this. That is going to be multiplied by the temp direction dot x, comma, the other dot transform dot position dot y is going to be called by it's going to be multiplied by the temp direction dot y. You can sort of get see where this is going at. We need our values here, the x position, the x coordinate of our player, to be multiplied with the temporary direction that we gave up here of our travel direction. Multiply those with each other, and the same thing with y, and of course the same thing with z. So we are going to say other dot transform dot position dot y, no, z, multiplied by temporary direction, multiplied by temporary direction dot z. There we go. Okay, that's as mathy as it's gonna get, I think, because actually there is another one. We need a vector 3. Come on, vector 3. Vector 3. Let's call it the temp minimum equals a new vector 3. And inside the calculation, we are going to need a transform dot position dot x plus the collider dot size dot x divided by 2. And that result is going to be called, of course, by temporary direction point x, comma. Now you can always make a new line. It's not that. The line only ends whenever you make a semicolon. So instead of having this extremely long line here, we could say, just to make it look prettier. Here we go. If you move it like this, then you can sort of like make it look prettier. And it's the same thing. The code is completely ignoring your line changes and so on. It stops when there is a semicolon. That's when the line stops. That's also why you could theoretically say these two would be exactly the same as doing like this. So let's say here we have our collider here, which is, well, the size of our collider, because it needs to know the size. Because if you in here in Unity change the size of this, the size of your collider here, if you use this up here, the scale or anything like that, then it gets tricky. So I would recommend that you change the size instead of the scale of whatever you're editing. Good. So here we have connected to the transform of that. So let's say here we need a transform. I can't spell transform for some reason. Dot position dot y plus the collider dot size dot y divided by 2. The reason why we need it divided by 2 is simply because, let's say your collider is 10 meters long in size. We need to make sure that our code understands that when you're halfway, then there's only 5 meters left. So it's 5 meters on each side to go between 0 and 1. It's not 10 meters, else it would be between 0 and 0.5 when you're all the way through. We need our code to understand that when you're halfway, it needs to be 0.5. That's why we're dividing by 0.5. There. We need to make sure that this is like this, and it needs to be multiplied by our temporary direction y. And we can do the same thing here. Transform. I still can't spell transform in the first attempt. Dot position dot z plus the collider dot size dot z divided by 2, and of course it ends, and it's multiplied by the same thing dot z, and here it ends. Ta-da! Well, actually, there it ends because we have 2 parentheses. All this needs to be calculated in one go. And our whole thing ends right there. So, and this here we could say would be the not like that. I'm going to make a comment. The minimum position of the collider in the chosen direction. Now, this type of system gets really sensitive towards if you rotate the collider, which is why me and Christian Schubert are going to include the advanced script if you download it from my website. That takes rotation into account. But in this case, just leave it at 0, 0, 0, and then it will work when you walk through the x-axis. Because that's the example that we're going to work with, because else it gets really hairy and you get You need long lists of math stuff to go through. And I don't know that. Programmers do. That's why you need programmers. This is why you need to just know your own simple thing and it'll work. And down here, there's an error I can see. It needs a comma. You see, there comes red lines whenever it knows that you're doing something wrong. And nobody likes red lines. It likes going to school. This right here, it establishes get the progress of the player inside the collider, which is what we are going to establish with our travel progression, which we have told up in the beginning of the script. Now, the next thing is that we need to establish the length of the collider. And we're going to do that by creating a temporary length float, which is a new vector 3. We are going to make sure that it is the collider dot size dot x, and it's going to be multiplied by temporary direction dot x, comma, and this is where we can go to the next line if we want to. We are going to say the collider dot size dot y multiplied by temp direction dot y, comma, and the collider dot size dot z multiplied by temporary direction dot z. End of transaction. No, wait, actually, because this is called magnitude, if I'm not mistaken. Yeah, because magnitude is also a mathematical value that it needs to know the length of the collider in the chosen direction. So now we have established the minimum size and position, and now we have chosen the length of the collider. The length is what we're going to walk through. And that's the thing. If you go for the more advanced script, it will take into account if you skew this into different directions. Good. And we need to make sure that this only returns a value between 0 and 1. And there's a very nice and easy function for that you can call, which will just clamp things and make sure that if you go below 0, it stays at 0. If you go above 1, it stays above 1. And it's called the value. Didn't we call it that? The value? Yes, the private float, which is what the entire value that we're going to need. Math f dot clamp 0, 1. You can also just write clamp and then say 0.1 like this, but 0, 1 is easier to use. Vector 3 dot distance, and the temporary minimum, comma, our travel progression divided by the temporary length of our setup. And that's the thing. So now all we need to do, since we have now calculated what is going on while we are inside the collider, we can go up here into our private void set audio mixer, and we can send here, say, set audio mixer the value. This means that this whole calculation is going on while we are inside the collider, and it sends the result of that, the value, which is equal to a clamped value between 0 and 1, between our temporary minimum, how far we are into it, divided by the length. And that's what we're going to send. So we're going to start this function here with that number. And that means that up here, we're going to have these calculated by that number here in the code. So our floats here will be 1 minus the value, or 0, nothing plus the value. And we have our smoothing value here. So this should work. Just to make sure that everything is as it should be whenever we're in it, public void on trigger exit, and that's a really easy way to make sure that values stay the way you want them. So if the value is greater than 0.5, like this, set audio mixer 1.0 f, else set audio mixer to set audio mixer 0.0 f. Now this simply here, when you leave the collider, it checks what is the value that you left it at. That means that if you leave the collider like not in the exact angle that you're supposed to, let's say you leave the collider at when the value is 0.8 because you leave it in a diagonal value, then it'll force the value, if it's above 0.5, to be 1, which means you'll go to the correct snapshot, and it will set the value to 0 if you're going the opposite direction, and that means that it'll set it to 0. So you don't never ever end up with being able to leave the collider at the wrong position and it'll go to the wrong snapshot or not fully transition to the snapshot. So let's see if this works here over in Unity. If we press play, funny enough, no errors. So this box collider here, actually this, if you press F, you can see this object here, and actually it's placed a little bit annoying. So let's find our first person character here. We can copy his position into this transform here. Here we are, so that our snapshot controller goes to where our player is. Press F and it goes right there. Now we know, I know, because the controller is really bad, that the player, our player character here will only walk in one direction. So let's put it there, and then instead of altering the size by going into this tool here, because if you do this, you'll see that it's the scale you're altering, and we don't want that. We want to alter this value here. So this here's our X value. This here's our Y value, and this here's our Z value. Let's move it a little bit so that we can make sure that he can walk into it. The character can only walk in one direction at a time. He can't change direction, so it's only forward, left, right, or backwards. So let's, for the sake of the example, make sure that we have a collider that works perfectly here. Here we are. So we need to establish that the mixer that we're going to use is our ambient mixer, and the snapshot that we're going to use is snapshot 1 and snapshot 0. And we need a smoothing value of 0.5. Before we can run into the collider, we need to establish here in our travel direction which way we are going to travel through the collider. And that can be a bit messy, and that's why we have the advanced script that we're going to include on the website, cujo.dk/scripts, where we're going to add all the scripts for this. This blue one here, that's sort of like the depth of this object, and that's the one that we need to use in this case. Now the problem with this is that actually, because this one is placed without any rotation in our world, that means that we need to go the opposite way, because Z goes not that way through it, it actually goes this way through it. So if we set our direction here to -1, it'll work when we go through it. Else you could set it to 1, but then it would need to be snapshot, you would need to swap the snapshots. There's tons of things to do with this, and in case you want to do more about this, then ask your programmer. But for the sake of the audio programmer, then no, for the sake of the audio designer, then this works as intended. So let's see while we walk through this here that it'll fade between the two snapshots slowly. Now, the interesting part comes when, let's say we make this collider massive. Basically cover the entire thing. Let's just make it huge. Let's say we cover the entire level like this. The level is a little hard to see, but it is down here. It's covered in fog. But let's say we cover the collider with the entire thing here. So once we press play, you'll be able to walk around the level and it'll just smoothen like this. So what I imagine is that you have another system that is the same system, but rotated 90 degrees. So you will constantly know where you are on this axis and where you are on this axis on the level. And then have two snapshots here on this mixer, and then maybe two snapshots on a mixer above this one, fading between two other mixers, so that then you can have this really nice flowing soundscape going. Let's try this out here. While we're running around this level, this value here will change over time. See, now it's 0.6, which means that you can have quite large rooms. It basically means that when we have run to the other end of the level, we will have different values, so that you can, with this, you can cover an entire outside area and then just connect these snapshots to, let's say, your wind sound. That means that you can alter your wind sound from this area, one area of the woods, to another area of the woods. It's a really easy system to do really cool audio design stuff with if you're working with ambient. So instead of having just two snapshots between two rooms, then you can have individual snapshots in both areas. Let's say you have an indoor house and a forest, and when you're inside the house, maybe each room in the house has their own snapshot and own system running. But then if you're on the left side of one specific room, maybe you want something else to play. You can do a lot of things with these. But this is how you crossfade between two snapshots, by running through a collider. The code gets a little tricky because of the math that needs to be done here, but I've made sure that all this is explained in these nice comments here. At least in case you want to do this and you find this too tricky, then of course you can always just show this script or the advanced script to your coder and say, this is how it works, because programmers, they can look at this probably for a split second and they will tell you, oh, I get it. That's what coders do. I get it, you know? That's all they do. And that's how it works. Anyway, that's how you crossfade between two colliders or crossfade between two snapshots. It's kind of easy to do. It takes a little bit of math, but it is possible to do. And it's way easier and way better to do than doing it over time by using the smoothing value, that where you do the transition to value like we did in one of the previous videos. And this here can not only crossfade between snapshots which are made for individual rooms, but it can also crossfade between whatever you want to set up on your entire level. And as a sound designer, of course, that's a great thing, because that means that you can now use this so basically as parameter control according in relative to where the player is. It's really useful. If you have any questions, please fire away in the comments and we'll figure out how I can help you, what we can do with it. If you have any feedback, let me know. And if you want to go download the scripts, it's at cujo.dk/scripts. I'm going to put it all there. The website's probably going to be really ugly, but they will be there. Hope you enjoyed this video. See you next time.